So now we want to talk about one pipe sizing tool. This is a pipe sizing tool on the Illinois Drainage Guide. And this is just one of many pipe sizing tools. They should all give you the same results for any situation, except maybe a pipe sizing tool which was developed by Esangani at the University of Michigan, because that takes into account the entry resistance into the tile drain. And that makes some difference. Most other tools just assume a certain entry resistance. This can be accessed from the Illinois Drainage Guide. So you go to the Illinois Drainage Guide, and on the drainage guidelines, there's a pipe sizing tool. And this is the one in Excel, and there is where the tool can be found. Now, some of the aspects of the tool, there's a section for displaying the results, and the results depend on the question that is asked, and that's located at the bottom section. There's a section for specifying the drainage material, and the drainage material would be either a single, dual, or clear concrete. And there's an option for others. For example, if you have like a galvanized pipe at an outlet and you want to design, size that, then you can use the other, and then you'd have to specify the roughness for the galvanized pipe, which is 0.23. And, so yeah, you can specify that here. Okay, then there is the drainage coefficient for the pipe. And the drainage coefficient is usually equal to or in excess of the design intensity at which the system is designed. So here you can pick a design intensity and use that as a drainage coefficient, or you could, in addition to these commonly used values, you could specify whatever value one is required. And these are some of the typical drainage coefficients that are used based on the design intensity for mineral soils and for organic soils, or for field crops such as corn or soybean, or truck crops such as horseradish or whatever vegetables, cucumbers, whatever vegetables are used. Field crops typically truck crops typically have use a higher drainage coefficient to move away faster because they're higher value crops. Okay. Then there's a section that you choose what your design parameter is, what output you want. The output can be the area, the tile size, the slope, the flow rate, or the velocity. And for each one, there are several options. For example, to determine the area, one could use the tile size and the slope, the flow rate, or the tile size and the velocity, etc. There's an option for sedimentation. So if there is if there's an existing pipe that one encounters and there is a 3 inches of sediment in a 12-inch pipe, one can determine what the new flow in that pipe would be, or determine the area that could be drained for the pipe as it is in the sedimented condition. There's a design chart which more or less shows the design point based on what's selected on the right-hand side. And this typically shows, for depending on what is selected, the intersection of 2 lines, which gives the operating point. This design chart can be printed and exported. It can be saved as a PDF file or as an image file, and it can be taken into the field for rapid use or can be put in other operation. There are many other drainage calculators. One such example is the Prinsco drainage calculators, where one can determine the drainage calculator by acreage, and there's one that can determine drainage by pipe size. And these two are like subsets of the pipe sizing calculator on the Illinois Drainage Guide. There is the iGrow drainage calculators, which have been incorporated into the transforming drainage sites, where there are several options. You can determine pipe size based on area drain, average hydraulic conductivity, drainage coefficient, etc. Length, maximum length of a pipe of a given lateral. And there are also options for pump size and some storage. It's like a comprehensive set of drainage calculations. There is drainage tools that were developed at Michigan State by Ehson Ghani, and these are fairly new, fairly comprehensive, and they cover many areas of drainage. To me, the most exciting one is the one for drainage spacing that optimizes the system for a 10-state region of the Midwest based on economic consideration. Optimizes the spacing based on that. But there are many other tools, some of which do the same thing as a tool on the Illinois Drainage Guide. There are other tools that, as I mentioned, these take into account the entry resistance into the pipe. So if you want to know the difference between a 4-inch tile with 4 slots or a 4-inch tile with 8 slots, then this actually calculates what the different flow for each one of these systems, or a pipe with a sock on or a drainage envelope. Then these systems give a more refined value. These tools give a more refined value for these systems. Now, here are a couple of problems that can be solved using the Illinois pipe sizing tool. In this instance, the question reads, and this question was taken from a hydrology book, which is no longer in print, developed by Jarrett. Says the corrugated plastic subsurface drainage line ABC has no holes, so it's a non-perforated pipe, and it's currently receiving water at point C from 5 acres of land, which has a drainage coefficient of 1/2 inch per day. And the question is, how many additional acres can be drained into this existing line at point C if the additional acre has a 2-inch per day drainage coefficient? Should I just give the answer now?
Can you show us how to solve it?
All right, to solve this problem, first of all, we need to determine what the capacity of the existing pipe is and what the current flow is. And then based on the difference between these two, we can determine how much flow can be added. And then we can determine the area given the flow for the system. To determine the capacity of the existing pipe, we determine the 2 sections. We determine it is the lesser of the capacity of the 2 sections. So we would determine the capacity of a 4-inch pipe on a 6% slope, and also the capacity of a 6-inch pipe on a 0.3% slope. And then based on that, we can determine which is the lesser of the two, because it is the lesser of the two that is going to control flow into the system. Once we determine the incoming flow, the capacity of the existing system, if we subtract the difference and obtain the difference, we get a difference of 2 cubic feet per second. And then we can use the tool to calculate area given the flow and the drainage coefficient. Okay, here is a sample calculation for a pipe with sediment, and pipes with sediments are often encountered when one is installing a drainage system. And then questions asked, should I ignore that pipe? Can I tie into it? What's the capacity? And this seeks to answer the question of a capacity of an existing pipe with sediment. In this case, when installing a new drainage system, I intercepted an old flowing 5-inch clay tile with about an inch of sediment. So it's about 20% sedimented. I want to tie this into the new system. Assuming it's on a 0.1% slope, how much water will it add to the system? What is the equivalent drainage area that I will be added to the system? And you're doing the design using a 3/8-inch drainage coefficient. So first of all, I can determine what is the flow from a 5-inch pipe. So I would determine the flow rate using the tile size and the slope. I would tell it the degree of sedimentation, and then that would say what the flow rate is in the system. Then, using this flow rate and the drainage coefficient, I can determine the area, which is another option of the tile. I can determine the area based on the flow rate and the slope, and the flow and the drainage coefficient. This is a question which I was asked by a contractor. There's this new 4-inch flexible dual wall, and he wanted to know what is the capacity of the system compared to an existing 5-inch single wall pipe. So we can determine the flow from a 5-inch single wall pipe on a 0.1% slope. So we look at the flow rate, and then we put in the pipe size, the slope, etc., and we determine the flow rate. So for a we can determine, what for a 4-inch pipe, we can change the roughness and determine what roughness it would have to be to have the same flow rate. And then based on trial and error, the roughness coefficient it would have to have is 0.0082. But this is a value is below the range for a smooth plastic pipe given in the engineering toolbox. And the smallest published roughness values for a flexible dual wall I've seen is about 0.012. So therefore, the 5-inch pipe would have a greater capacity than this new 4-inch pipe. But we can determine the actual capacity of this 4-inch pipe by putting it in as putting the roughness of 0.012 or whatever roughness the manufacturer supplies, and then determine what the flow is. In this case, the flow in that would be about 60% of the flow in a 5-inch single wall pipe. Okay, and so that's the tool and a couple of examples. Thank you.